Hello everyone, this is Tao Yang. I'm a PhD student from University of Southern Denmark. Today I will present the development of Modelica Building Emulator for model predictive control applications. This is my agenda, the presentation plan for my presentation. First, I will go to the introduction with the background and the motivation of the work. Secondly, I will talk about the methodologies I used in the model, such as the building OU44 description, the modeling approaches of the emulator. After that, I will present the result for both simulation and validation, and also how the result would be for the updated model. And after that, finally, I will join the conclusion based on those presentations above. Getting into the introduction part, for the background and motivation, as we know that buildings are responsible for around 40% of energy consumption overall, and it is important to reduce energy consumption from buildings' energy systems. One potential and good solution could be using the advanced control strategies such as MPC, model predictive control, to reduce energy consumptions in buildings. However, most of the MPC applications still remains in research area instead of real applications in industry. The reason there are still a lot of barriers that we have to overcome before the wide application of advanced control strategy in industry. Those barriers could be the performance risk, the installation cost. For instance, what if the advanced control strategy doesn't perform as we expected? So in this way, it might be good that we have a test bed, we have a platform that can test our control strategy for the building advanced before it is finally implemented in the real buildings. There is actually one ongoing project, IBPSA project 1, and under this project, one of the subtasks, work package 1.2, is actually doing this job. It is to develop the building optimization performance test called BOBTEST, which allows users to provide the building model into the platform and commission the control strategy themselves, and then make the simulation and optimization, and then report the performance, make comparisons. Under scope of BOBTEST, it is defined that it would be good to have some reference model for the BOBTEST that the users can use to test and make a comparison. One of the defined selected reference model is one single room commercial building, which is actually the model, the work that we are presenting in this presentation. So basically, this is a motivation. Why are we doing this? Just to provide an emulator to feed to BOBTEST for the test and the performance comparison. Talking about the methodology for the emulator, first let's look into the detail about the building OU44, these buildings that we are modeling. It is a university teaching building, and this is schematics of building energy systems. It has a CO2 driven ventilation system, and it has district heating and collective building. It basically has two branches. One goes to the indoor room to a radiator to provide heating. Another branch proceeds to the ventilation coil to preheat the supply air. And there is and the domestic hot water is not considered in the model. this is the basic information about the model. It has around area around 8,500 cubic square meter, can accommodate maximum more than 1,000 people, and there are 3 above floors and 1 basement floor level containing the main HVAC facility and heat exchanger connected to district heating. For the ventilation, in reality we have 4 ventilation units, each with a rotary heat exchanger and for reclining heat for exhaust air, and we also have the heating to the room is provided from both radiators and the ventilation part. As we mentioned in the previous slide, this model will be modeled as a single room, and it will use Modelica Buildings Library to develop it. The reason we are using single room is that, first of all, it might be good that we try to check how the single room can capture the thermodynamics of the building. And it could be reasonable or not. The second is that for the entire building, for the more detailed model, we actually lack some important data which is necessary for the detailed emulator. That in this way we are thinking the single room may be a possible solution to provide this to develop this emulator and serve it as a reference model. When it comes to the modeling approach, first of all is the building envelope. This is data that we taken from the documentation directly. For the HVAC system, we mentioned that 4 air handling units are presented, and then in this one single room model, we just use a single air handling unit, which is oversized by a factor of 4 to represent the reality, and all the radiators are lumped with one single radiator. For the occupancy, we have installed the camera-based sensors in the building. Therefore, we have the measurement from the sensors, and the internal heat gain per person is assumed to be 120 watts, and it is evenly distributed over the floor area. Also, there are some other boundary conditions, data, and important assumptions showed on the right side, such as weather profile and ground boundary temperature, infiltration model, and the shading and the lighting. As for controllers, and this controller will be showed in the next slide. This is a model that we developed eventually in one single room showed here, and this is a room, this is occupancy, this is a ventilation unit, which is showed in detail in this here, and this is a district heating network showed here. Generally, we have 3 controllers. One is control the CO2 level of the room to a specific level, and the second one is trying to control the supply air temperature in the ventilation unit. The last one is normally this T supply is set to 21, and the last is indoor room temperature of the room, and this controller will just control the heating supply from the radiator to meet the temperature set point of the room. Now we'll talk about the simulation and the validation. So BOBTEST requires 1 year data to be supplied in the simulation and optimization. Here we only simulate and validate in January. The reason we choose January is that basically in Denmark, January is a month that use the highest heating power in this month, and also it has heavy teaching activities, which indicate that a lot of occupancy. So it might be good that we take the measurement from this month to validate against the simulation data. So one question is how the indoor room temperature set point should be in this model. Then first I check the indoor temperature of the building measurement from several represented rooms, which is shown in this figure. As we can see, the indoor room temperatures are always around 21, which is which means even during the night and weekend, which means that if we set the room temperature set point to be 21 would be reasonable, and the simulation result can be compared to the measurement. So the only data we can validate from between the simulation and the measurement is the heating and the ventilation consumption in January, and those two values are taken from the previous work, which is showed in these two figures. In January, it's basically the actual heating is around 70 megawatt hour, and the actual ventilation is around 2 megawatt hours. And we will compare this two values with the simulation. Now, so for the initial model setup, for the validation, the room temperature set point is 21 Celsius degree. Then we get the simulation result showed in this curve with the blue one. So basically, the indoor room temperature is around 21, and the CO2 concentration can be maintained under 80 ppm, and also we have the occupancy data, we have the radiator match rate, and also the radiator power. And after getting this, we also have the calculate the values here, which is total energy consumption and also the fan. These two values will be compared to the previous value to the measurement. Based on those, we consider the model is reasonable for the initial model setup. After that, we actually consider how good we are thinking this temperature set point of 21 might be not good to look into the building thermal behaviors. So we changed to another set point of 21 during the day and low heating supply during night and weekend to just check how the building will perform, how the indoor temperature will evaluate through, and when there is no heating supply, which is showed in this orange curve here, and the comparison result is also the data is also showed here, and this figure also shows the data of this table. In general, I would say this model is kind of reasonable and is capable of mapping energy consumption of the whole university teaching building, and at the same time demonstrate reasonable indoor temperature and CO2 concentration. And now we can conclude that the emulator is ready for Bob test and will be open for any testing in GitHub. That's a presentation. That's the end of my presentation. Thanks for your attention.